Okay, so today's video is looking at the dot point outline the structure of the human larynx and the associated structures that assist in the production of sound. So the larynx, which is also known as the voice box, is positioned in the throat, where the back of the throat, known as the pharynx, divides into the trachea and to the esophagus, so right down here. The larynx has two main functions in communication. So firstly, it needs to provide an open airway, especially when breathing, and to provide a mechanism for sound production, for example, when speaking. A third function is to ensure a closed air channel during swallowing, which prevents food or drink from entering the trachea, which is brought about by the closing of the epiglottis. The larynx is a hollow box that houses the vocal cords that are sometimes referred to as the vocal folds. In humans, its structure basically consists of a framework of 9 cartilages joined by membranes and ligaments. These form a box known as the voice box in which sound can be produced and resonate. The upper opening of this box is called the glottis and is often covered by the epiglottis, the uppermost cartilage of the larynx. The epiglottis extends from the posterior of the tongue to its anchor point on the anterior rim of the thyroid cartilage, so the back of the tongue to the front of the thyroid cartilage. Being flexible and spoon-shaped, it tips forward over the rising larynx during swallowing and prevents food from entering the larynx and trachea or the windpipe. When only air is flowing into the larynx, the passage is wide open and the epiglottis is held away from the larynx. So basically, the epiglottis's job is to stop us from choking when we're eating or drinking. The large cartilage ring, known as the thyroid cartilage at the top of the larynx, is composed of 2 bands which at the join often develop a prominence commonly known as the Adam's apple. Inferior to this is a cercoid cartilage, which is attached to the trachea at the lower edge. 3 pairs of smaller cartilage form part of the lateral and posterior walls of the larynx. The most important of these are the laterally placed arytenoid cartilages because these anchor the vocal cords. Muscles connect the cartilage to the head or neck, while others alter the position, shape, and tension of the vocal folds or the vocal cords. The interior of the larynx has a mucus-coated lining. Cilia or hairs on the mucus lining below the vocal cords push substances towards the pharynx. The action of clearing your throat helps to move mucus up and out of the larynx. Lying under the mucus lining on each side are the vocal ligaments. These join some of the cartilages to each other and in doing so draw the mucus lining up to form the vocal folds or the true vocal cords. When viewed from above, the right and left folds form a V shape. True vocal cords vibrate and may produce sound as air rushes between them from the lungs through the opening called the glottis. Above the true vocal cords, there is another set of mucosal folds called the vestibular or false vocal cords. These play no part in sound production, but the mucus produced assists in lubricating the true vocal cords. These false vocal cords also snap shut if they come in contact with liquids, preventing them from entering the breathing passages during drinking. Phonation is the name given to the complicated process of producing intelligible sounds or speech. So in other words, the sounds that humans are able to create in order to send intelligent messages. The process is roughly divided into 3 stages. Firstly, the production of airflow. Air is expired from the lungs automatically as we breathe and as we speak. The force of air must be great enough to push open the vocal cords. This is achieved by the relaxing of the diaphragm muscle to form a dome shape and the external intercostal muscles between the ribs so that the pressure inside the chest cavity is higher than outside the body. Thus, air is forced out in an attempt to equalize the air pressure inside and outside. The airflow can be altered in various ways, such as exercising, holding one's breath, talking, and shouting. Secondly, we have the production of sound. The rapid opening and closing of the glottis set up the vibration pattern which produces sound. This results from the release of air from the lungs and the vibration of the vocal cords. The length of the vocal cords and therefore the size of the glottis is controlled by the vagus nerve, which is the 10th cranial nerve. One of this nerve's functions is the contraction and relaxation of the muscles and consequently the movement of the attached ligaments and cartilage. The shorter and tense of the vocal cords, the faster they vibrate and the higher the pitch. The glottis is wide open when we produce deep notes and just a narrow slit for high-pitched sounds. A teenage boy's larynx enlarges comparably more during puberty than does a girl's. Thus, his vocal cords become longer and thicker. They vibrate more slowly, resulting in a lower pitch or a deeper voice. The volume or loudness of the voice is controlled by the strength of the airflow. The greater the airflow, the stronger the vibration and therefore the louder the sound. Thirdly, the articulation of voice. Sound is an important medium for communication in humans, particularly if it is intelligible. This modification of sound we call speech. The vibration of the vocal cords only produces a buzzing sound. The resonance or quality of a voice is determined by other structures situated above the larynx, such as the pharynx and various sinuses, and the cranium. Sinuses are air-filled cavities which are lined with a mucous membrane. There is a significant change in the voice when a person is suffering from a blocked nose, sinusitis, or a sore throat, whether it be pharyngitis, laryngitis, or tonsillitis, which is the swelling of either the pharynx, larynx, or tonsils in respective order. Finally, in speech, the sound must be shaped into vowels such as A, E, I, O, and U, or the consonants which make up the other letters of the alphabet, by the muscles of the tongue, the soft palate, which is the roof of the mouth, the cheeks, and the lips. These are known as the associated structures that assist in the production of sound. So when you talk, you can feel your mouth changing its shape in order to create the different sounds. So that's as a result of those associated structures, whether it's your tongue, your cheeks, your soft palate, or obviously your lips. So as we can see in this video, the glottis opens and closes as the air passes through the larynx, and the vocal cords vibrate to produce sound. Towards the end of the video, you will see the vocal cords vibrating very fast to produce a high-pitched sound.
Hello! I haven't had visitors in so long.
What are you?
I'm a voice box. Some people call me a larynx. See my two vocal cords moving apart and together as I talk? They come apart so that the air can get through them, and they come together to vibrate and make sound as I exhale. Let me show you.
So in your booklet, you will find some instructions for 2 short practical activities to look at the production of sound by the vocal cords and the associated structures involved in creating intelligible sounds. You need to collect the equipment and work through these activities in groups of 2 or 3, and then you need to work on the secondary source investigation that looks at gathering and processing information from secondary sources to outline and compare some of the structures used by animals other than humans to produce sound.